Hello, in this today's ICP, this is the first ICP of deep learning. So in this ICP, we are going to train our model with some information, like some physical information about some data, which allows the model to recognize the similar data or recognize or when you give any sample data to it, it will recognize whether this data belongs to the particular data it is trained under or not. So today we are going to do three tasks in this deep learning ICP. So the first thing is to feed the diabetes CSV file data to the model, and I'm also checking how the data accuracy changes while the dense of the data layers increases. So first I have so in this deep learning we are going to do the ICPs with the keras package. So first import all the required packages you need. So I'm importing pandas, keras, and the dense and activation packages from keras. So after that I'm importing pandas and numpy because you are dealing with the data sets, you need pandas and numpy. So and here in the dataset variable, I'm reading the diabetes CSV file, and there are no header values in this diabetes file. So I'm keeping it as header equal to none. So after that, I'm using the train test split in order to divide this diabetes CSV file to train data and also test data. The train test data split divides the data into training data and testing data based on these attributes. After that, so I am selecting the random seed here is 155. So for the every 150 in the every 155 sets of data, it selects randomly. After that, I'm declaring a variable my first, and then in the like in sequential, like here I am creating a sequential model. So after that, I am adding dense and input dimensions and activation attributes to this model. After that, I'm adding another layer of dense. Now we will see how this dense layer changes the accuracy of the model's prediction. After that, I'm adding the output layer and the activation, and after that I'm compiling the loss, the optimizer, and the metrics of the data testing. And after that, to this model I'm fitting the x train and y train values. So it will x train and y train values, so it will display me what are these values are. After that, I'm going to print the summary and also evaluating the x test and y test values, like what are the accuracy of these both test values. So I'm going to run this, and here you can see it is printing all the summary of the data. So let's see. So this is the accuracy of the data that has printed. So now I'm going to add like another layer. So let's take it as 40. So I have added another dense layer. Let's see how the accuracy changes. Here you see it is 0.7 and 0.5. And after adding another layer of dense, the accuracy has changed to 0.54 and 0.72. It doesn't improves in a mature value, but anyways it improves. So the next task is to include the remove the diabetes CSV and replace it with the breast cancer CSV file. So in this CSV file I have to see how the data accuracy changes while using a different data set. So in this data set there are header values, so I have removed the header equal to none attribute, and after that here I have to select the input values that I'm going to feed to the model and the target value. So here in the data set I have taken each and every column from the 2 to 31 column of the data into the testing, like the training and the first column, which is the diagnosis column, is into the target one. After that, I'm creating a encoder variable which is label encoder. So I am saving the label encoder model to into the encoder variable. So whenever I call encoder variable, it calls the label encoder. And after that, I'm going to fit this y value into y, which encodes the y and transforms it, and it fits into the y variable. After that, I'm using the train test split to divide the test and training data. And after that, I'm creating the model. Similarly, I'm adding the dense values, input dimensions, and everything. After that, I'm fitting the x train and y train values into my model, and after that it will test, and I'm printing the summary, and also I'm evaluating the accuracies of the model. So let's see how the accuracy for the breast cancer dataset. So here you see the accuracy is changed like this. So for the next part is normalizing the data. Why we should normalize the data is normalization really improves us to it improves the accuracy of the model. Whenever you take a data set, it may contain duplicate data. So normalization helps in reducing such type of duplicate data. So it removes the duplicate data, and it makes the model to work with more ease, and the model works more effectively after doing the normalization. So in order to do the normalization first, in this it is a kind of pre-processing the data. So from SQLM pre-processing, I'm importing label encoder, and also let's see here the standard scalar. I'm creating a SC variable, and declaring the standard scalar. Like, this is the normalization method we are going to use for the normalization. So I'm importing standard scalar into the my program, and I'm here declaring this method standard scalar, which uses for the normalization. So after normalizing the data, here I'm normalizing the training data. I'm normalizing the testing data. So after doing that, I'm going to create my model again, adding that dense layer data and every data to the model, and also fitting my training data into the model, and after that printing the summary and also evaluating the test values. So let's see how the score changes after the normalization. So you can see how the value has improved. It has improved almost to 0.96. So this is how the normalization works. So this is today's ICP. Thank you.